Johnny here. I just wanted to do some quick examples over the angle measure homework. Quick examples. So something you might see in the homework. Like this, if I want to convert negative 690 degrees to radians, I know if I want to convert from degrees to radians, I'm supposed to multiply. I'm going to take this negative 690 degrees and multiply by pi radians over 180 degrees. Now that's a big number. There's actually maybe a smarter way to handle this is to find a coterminal angle to this that's smaller, but I know I'm supposed to do this, so I can go straight to it. I can simplify as I multiply straight across. Both 690 and 180 are divisible by 10, so I can get rid of those zeros. And then they're both for sure divisible by 3. 69 divided by 3, that looks like 23, I think. And then 18 divided by 3 is 6. Let me just make sure about that. 3 goes into 69. 3 goes into 6 twice. 2 times 3 is 6. That goes evenly. 3 goes into 9 3 times. Yeah. So maybe if you need to do some arithmetic just to make sure, that's fine. But this is going to be negative 23 pi over, zeros are gone, 3 goes into 18 6 times, and I don't see anything else to reduce. So I believe negative 690 degrees is not pretty. It is negative 23 pi 6 radians. Yeah. All right, maybe box my answer just to show that that is the final answer. Let's do now the other direction. Let's convert pi ninths to degrees. Pi ninths radians to degrees. Similarly, I'm going to multiply. This time I'm going to put the pi radians in the denominator, and I'll put the 180 degrees up top. And again, as I multiply straight across, I'm going to look for something that reduces. 9 will go into 18 twice, so 9 will go into 180 20 times. Pi's go away. Pretty simple. Pi ninths is equal to 20 degrees. Just before I continue on, another way to maybe think about this is if I were to draw this in that standard position. I may not know where pi ninths is at this moment, but pi ninths is a third of pi thirds. So this is a degree that I'm comfortable with, 60 degrees. It's a radian that I'm comfortable with, pi thirds. If you have that one kind of visually in your mind, then pi ninths should just be a third of that. Meaning, if I were to take pi thirds, or 60 degrees, and cut that into 3 equal parts, then this is 20 degrees, 40 degrees, 60 degrees, or you can think of it as 1 pi ninths, 2 pi ninths, and this would be 3 pi ninths, which reduces to pi thirds. May or may not make sense at this moment, but I just wanted to give you a kind of a visual of this problem, converting pi ninths into degrees. Oh yeah, let's draw negative 5 pi thirds in standard position. That is, I need a Cartesian plane, the x and the y axis. A negative angle goes clockwise, and then I need to count out 5 pi thirds. So probably what I want to do is first convert this into degrees, something that I'm more familiar with. So I'll let you pause the video and go ahead and do that. I get negative 300 degrees, which is sitting here in quadrant 1. That's kind of boring. I think you can move on. But while I have your attention, let me show you maybe another way to think about this. Again, with that visual. This may be confusing. It's okay. Pi thirds. I know what negative 1 pi thirds looks like. We just said it's equivalent to 60 degrees. So negative pi thirds is the same thing as negative 60 degrees. And I'm going to start counting by those 60 degrees, or by those negative pi thirds. Another one of these would be negative 120. Or negative 2 pi thirds. So negative 60 degrees, negative 120 degrees, negative 1 pi third, negative 2 pi third. Another 60 degrees will get me to 180. Another pi thirds will get me to 3 pi thirds, or pi. Oh yeah, and we knew that fact. If you converted this first to degrees to get negative 300 degrees, then you know that 180 degrees is equivalent to 1 pi. I'm just going to continue. I'm going to do another 60 degrees, or another pi thirds. So negative 1, negative 2, negative 3. This is negative 4 pi thirds. In degrees, negative 180, and another deeper into the whole 60, that's 240. I'll do that one more time. Another pi thirds will get me to negative 5 pi thirds. That's what I'm looking for. Another 60 degrees into the hole, or in the negative region, is negative 300 degrees. And I know if I went another 60 degrees, I'd be a full revolution, 360 degrees. If I went another pi thirds, I'd be at negative 6 pi thirds, which is negative 2 pi, which is a full revolution around the circle. Okay, let's draw this maybe in blue. Negative 5 pi thirds is this blue angle I'm drawing. It starts on the positive x-axis. It goes in the negative region, and it looks like this. So however you got there, if you got there by first converting this to degrees, negative 300, it should look like this blue angle. Or if you count it out by 60s or by pi thirds, you should end up at negative 5 pi thirds. We'll do some more of this counting method in another video. So if you're just comfortable with converting, that's where you should be. Good. One more. What is the radian measure of a central angle that cuts away an arc 3 inches long in a circle with radius of 4 inches? Okay, that's a lot to handle, but we're talking about a central angle, so I'm going to draw a circle. Remember, a central angle is just an angle with its vertex at the center of a circle. Just to keep my mind, to help me out, I'm going to draw this in a standard position. So one ray, I'm kind of picturing it on the positive x-axis. Another ray is just kind of wherever it falls. I do have some values. If the radius is 4 inches, this distance is 4 inches, and the arc, that's 3 inches, shouldn't be longer than that. It should be a little bit smaller. So I'm just going to do my best. Maybe that's 4, so 3 is about here. I'm just estimating. There's my central angle. It cuts away this piece of the arc at 3 inches, and the radius of the circle is 4 inches, and I'm asked to find the radian measure of that central angle. I'm looking for theta. This is going to be pretty simple, because what is the definition of radian measure? Theta is equal to that intercepted arc divided by the radius. Theta in this game is equal to the intercepted arc over the radius. I'm done. This is 3 fourths, radians. Nice and simple. So if I ask you for arc length or radian measure, we're just using this relationship here, that theta is equal to S over R, or S is equal to R theta. All right, get your homework done. See you next time.